Um, Welcome everyone to the SEEDS seminar series, which is part of the Satellite-Enabled Earth Observation and Digital Solution for Agriculture program. SEEDS is a collaborative initiative led by University of Maryland Geographical Sciences Department and Sixth Grain, focused on building capacity in Earth observation, AI and digital agriculture across Africa and the global south. This seminar will bring together experts and participants to expert on how data and technology can strengthen food security, national and at the national and like a farmer level. And we want to explore and to show how we can use remote sensing and digital tools in agriculture. So to start us off, I will now hand it over to Dr. Molly Brown, who will give us an overview of today's agenda and share a preview of the upcoming sessions in the SEED series. Molly, you can take more time if you want. If this is necessary, I think we could kick off. Thank you everyone for being here, and please don't forget to fill the form that I will be sharing again, the link, just for us to give you more notice and notification our upcoming events. Thank you, everyone.
Excellent. Thank you all so much for joining. My name is Molly Brown. I am the Chief Science Officer of Sixth Grain, as well as a research professor at the University of Maryland Department of Geographical Sciences. Because I wear two hats, working for both institutions, I have been able to see the enormous strength of University of Maryland in its development and use of satellite data, development of algorithms, producing state-of-the-art data, products, and really fascinating research. At the same time, Sixth Grain works in the field, as they say. It works with companies, governments, NGOs, and other organizations to take those data products and deliver them to decision makers to make sure that they are able to use the information that all of those great scientists at University of Maryland are producing. So it made a lot of sense when Waleed actually suggested that we work together to produce this seminar series. As you can see on the agenda, we're going to start with Dr. Allison Bredder, who works for NASA Harvest and who will give an overview of both NASA Harvest and NASA Acres, I think, and will explain how NASA, as a premier organization which provides satellite data and funds research, how it goes across all the different agricultural institutions to deliver real value. Then I will give a talk on food security, which is my primary research focus at the University of Maryland, and where I'll just give a background, and I won't go into it because I'll speak at 10:30. And then we've invited two of our very close colleagues who have worked with Sixth Grain for the past 10 years, Mario Kuntz and Pete Veal, who will give some examples about digital agriculture solutions that Sixth Grain has been developing, and Pete will give some practical examples about how remote sensing is used in agricultural technology firms. I can tell you that if you are interested in agricultural remote sensing, waiting to hear Pete and his talk is going to be super fascinating, because he has been working and has been using satellite data, but also information to drive the company work that they're doing in order to figure out what their clients need, how to deliver that information. It is really challenging and fascinating. I've learned so much by engaging with sixth grade over the past decade. Then tomorrow we will move on to climate change and risk. How do farmers use, what risks do farmers are exposed to? And particularly Dr. Marcus Enkel from the World Bank will be talking about next generation drought risk financing, which uses satellite data in order to understand how risk is captured and how we can use satellite data to not only understand exactly what the output is, but also to drive operational products which can help us understand in order to intervene early and to make sure financing is available. And then finally, irrigation, which is a absolute game changer when it comes to surviving drought all over the world, US and everywhere else. How do we identify irrigated land? How do we understand the places that irrigation should be used more, et cetera? So Sheila Baber is going to be talking about that. I'm very interested in that because I can tell you that it seems really easy. How hard can it be? You just find the places that are greener than they should be. It's super complicated and it's very, very challenging to determine whether or not irrigation is sufficient to maintain yield. And that is really a huge challenge, particularly in places that do not have nicely monitored flow meters, et cetera, which is almost everywhere. And then finally, on Thursday, the 16th, we will have wheat mapping and production of crop and cropped area estimation. And how do we use modeling to better understand in process models to figure out if you know where the crop is, how well is it doing? And Dr. Ensley will be talking about that. And then on the last day, we have making sense of the data, right? So harvest stat is going to be ground information if you needed to know about yield data and how it's collected, which is a huge challenge, and absolutely I'm fascinated and I can't wait to hear about how HarvestStat has been doing that. And then Jordan Caraballo is going to talk about how deep learning and AI and how we can use AI approaches to leverage to all the information presented previously. And then finally, Dr. Sergey Sakun is going to say, how do we know if the data is any good? And that's a huge challenge for everybody. And the area estimation and validating product accuracy is a really critical, and understanding the value and the accuracy of data is really important. So that last talk, very, very important to attend if you can. Okay, so that gives us a good overview. I will be online the whole week. You can text me in the text. If you see there, the chat there, if you click on host and panelists, you can click on my name and send me a direct message, or you can email me. I'll put my email in the chat bot, or you can simply Google me. Now I'll send it back over to Waleed, who will introduce our first speaker of the day. Thank you all so much for attending.
So thank you, Molly, for this large overview. I will directly give it to Alison to tell us more about the use of remote sensing for agriculture. And just to say, don't worry, we will send the please just fill the form, and we will say send the recording at the finish of every day. Okay, it's for you.
Sounds great. Everyone can hear me good? Waleed, everyone? Great. All right, so thank you for that introduction, Molly, and Waleed, and also for everyone who's organizing it. I'm really happy to be here and sort of kick off this workshop series. So I'll start by introducing myself a little bit. I'm Allison Bredder. I'm the Strategic Engagement Officer for NASA Acres. I'm also formerly a postdoctoral associate at the University of Maryland. So most of my day-to-day is engaging with our partners who are part of the NASA Acres Consortium, which I'll get into details, and I'll go a little bit over harvest as well. And then also engaging with folks who are outside of our consortium. So my background is in remote sensing, mostly optical remote sensing, and also wildfire and air quality. So I'm focused now on agriculture. And if you were like me, not so long ago, I do have links and QR codes to free resources. If agriculture is not your bread and butter, there's a lot of really great free resources that are provided for you. A lot of government sponsored ones by NASA and original ones from the National Science Foundation, where you can really get a deep dive into how to use remote sensing, different tools, different coding packages. So that's just a teaser to get you to stay sort of for the whole talk. So I'm going to progress now. And if you want to also on the QR code here, it takes you right to our website. You could also just Google us. We're NASA Acres, and it should pop up, and I'll have more QR codes for you during the presentation. But what the heck is NASA Acres? So if folks are outside of the US, you might not have heard of us. And maybe if you're in the US, you also haven't as well, because we're relatively new. So NASA Acres is NASA's consortium focused on US agriculture. So you might have also heard of NASA Harvest, which some of the speakers are also affiliated with or were at one time. So we sort of work in parallel. NASA Acres focuses again on US agriculture. NASA Harvest focuses more so on global food supply. NASA Harvest preceded NASA Acres, and in 2022, through a competitive proposal process, NASA selected NASA Acres as its US focused consortium, sort of to extend the efforts that NASA Harvest had done for years prior. So we have an initial 5-year award. And so our mandate and our mission is to strengthen US agriculture. We have over 40 organizations that are private, public, NGO, universities, and our main mission is to bridge the gap from space to farm, education to impact with US farmers and ranchers and other people who are in the agriculture community broadly. And sort of this effort builds off of NASA being associated and supporting agriculture for the past 50 years, back when we had weather satellites in the 70s, utilizing that technology, then to focus specifically on agriculture. That was one of the first applied areas for NASA to support was actually agriculture, which I don't think is too well known. You can see on the map on your screen here, we sort of operate as a hub and spoke model. So imagine like University of Maryland is where NASA Acres, we call our operations team, is built out of. So Dr. Alyssa Whitcraft runs our consortium. Our deputy director is Dr. Michael Humber. We have Jacob Orzer, who is our program support specialist, and I round out the team at University of Maryland. So that's where we're based out of. And then you can see these extensions coming out of the University of Maryland hub here. And that is sort of the people who are our research, development, and extension partners. So you can see we have folks at Cornell University, which I'll get into a lot of their really great research. We have folks who are all the way out in Stanford, David Lobel, Arizona State University, Hannah Kerner, and then folks all across the US here. So we call the folks who are in the sort of like black markers here are doers who are doing really wonderful and cutting edge research for different applications for agriculture. Great pathology, cover crop mapping, and field boundary delineation. So we have folks doing a whole suite of things. And if you go to our website from that QR code, you can check out our full suite of projects. I don't have time to go through all of them here today, but I'll have my contact information at the end, and you can feel free to reach out to me with any questions you have about our great projects that are happening. And so next, this slide, I just want you to see and be like, wow, that's really busy. That is sort of the takeaway I want you to have from this. And it's really just to demonstrate that NASA Acres has a large structure, and we're really focused on a few focus areas. So in the middle here, we have in the gray, we have focus areas under our science team, who is led by Dr. Kayu Guan. He's our chief scientist. We have essential agriculture variable development, which I'll get into as well. And then we have our Farm Innovation Ambassador team, which is a new initiative that we're really excited about, but I'll also get into a little bit more details as well. We have our program foundations in the orange, and that's sort of what I described as our house here, headquarters in Maryland. And so we provide data infrastructure, communications, identifying new funding and engagement, which is mostly my role. We have what's called a recommendatory committee. If you look up in the dark gray, they receive feedback from the science and also our Farm Innovation Ambassador Committee, and advising what we envision as a NASA Acres Executive Committee. And our Executive Committee in the blue here, we have different NASA Acres leads, and they implement pathways for us and recommendations for our executive director. And most of that is this structure. It looks a little bit hierarchical, but a lot of it's very, we interact with each other in sort of a lot of ways through science, also communications, events, etc. So the main takeaway here is just we are small, but we are mighty. And so next, just talking a little bit more about the consortium. So we have three sort of areas that we want to make an impact in, and we strive to excel in. Sort of richer knowledge about the past and present agriculture, more tools getting into the hands of farmers, ranchers, and other people who are part of the agri-food system. And then one aspect that I'm going to talk a bit more of a highlight from this past fall is we want a stronger agricultural workforce that are ready to really tackle the challenges of extreme climate, weather change, and also food supply. And so we do this through a lot of science. So we have satellite remote sensing, modeling, we have economists on the team, and also through infrastructure systems like law. And I'll get into that a bit about our trust infrastructure boundaries that we've made, and also communications, making sure that folks know about the great stuff that we're doing. And so we have a few impact areas, and I'm not going to be able to get through all of these today, but I do want to mention that we want to focus here on just a few of trust infrastructure, user-friendly, privacy-protecting systems. We also work on better satellite methods a lot through just doing our science, an increased understanding of US agriculture, our co-developed user-driven tools, our workforce development, and then feeding into our findings into the continuity of high quality satellite data in order to serve agriculture. This could be informing missions, products, etc. I'm going to dive in first, talking just a bit about highlights on these sort of highlighted impact areas. And the first one I want to mention is trust infrastructure. And so here in 2024, NASA Acres launched what we call our core principles for agriculture data use to meet sort of farmers where they are. And so this is on our website as well. And basically, it guides the rules of engagement with farmers. So we're really proud of this. because the Ag Data Transparent Board, their board of directors gave us sort of a letter applauding us for this work to assist researchers and users of satellite data with proper data governance. And that's sort of a term that we use a lot in our work, just making sure that essentially when it boils down to it, people who are using data from the farmer who are using satellite data, everyone is comfortable with that exchange. And I'm going to get into a little bit more about why this sort of matters. And a lot of it is coming from a survey that NASA Acres conducted in 2024 of over 1,000 farmers in partnership with an organization called Trust in Food, which is a farm journal initiative. And so these farmers are asked a suite of different questions. And so if you have some familiarity with farmers and sort of the equipment that they use, a lot of the equipment can be very high tech. It can collect images. Some are using LiDARs and large combines. Farmers will also have captured data on soil moisture, data on yield. There can be a suite of information that they use in order to make their decisions on harvesting, crops, fertilizer use, water use, etc. Just a whole bunch of decisions that need to be made in order to make the best farm decisions. And so some of the key takeaways from this survey were that 50% of the farmers surveyed do see the benefits of using satellite data, but only 27% of those surveyed were actually trusting and sharing that data with others. And so the main goal from taking these survey results was we want to make the risks associated with sharing data lower. So that's an action that NASA Acres took. And we've been implementing work in order to address that concern that sharing data is not a safe enterprise, essentially. And so going to another one of the impact areas that were mentioned is sort of companies and researchers, especially if you're in the ag space already, you're a practitioner, you're a professor. We use models that combine satellite data from the different satellite missions with farm data in order to answer questions that we want. Like, for example, what's the yield forecast going to be next season? Or we can hindcast and say, do our yield forecasts actually match what the census took? But for those initiatives, researchers will also keep these models private for intellectual property reasons. You don't want people stealing your intellectual property or publishing sort of before you in sort of the academic sense. But this sort of creates this trust gap that slows progress towards more, productive and sustainable farming. So usually we don't frame it as the fault of anyone, but sort of we operate in sort of two different worlds, right? We have farmers who are gathering data to make on-farm decisions. And then for us at universities or in other companies, we have the intellectual property of our models. And so in order to address a lot of these system boundaries and challenges, we're working on building sort of privacy protecting computational systems that will safeguard privacy of folks who are giving their data, but also let you conduct the innovation that happens when you combine the satellite data and the farm data. And this has evolved into something called a confidential clean room, or CCR. And so NASA Acres and also another initiative that's directed by our executive director, Dr. Alyssa Whitcraft, through a Harvest Sarah initiative, they partnered with Microsoft to test a system where data and the models stay encrypted and they never leave their actual owners. And so we developed this sort of shared governance, this governance word that we use a lot, contract, that controls who can actually see what's happening in this clean room. And basically it ensures that the farmer data and the company IP are protected at all stages in the process. And so this is in initial stages. This is work that's spearheaded by Dr. Guanyuan Choi at the University of Maryland. And sort of the team ran 2 different models, machine learning and process-based processes using real soil carbon data from 44 farms. And they were able to show that they were able to protect the intellectual property of the models and also the privacy. So we're really excited about this. And it matters because it is a breakthrough that shows that farmers, researchers, and companies can collaborate in this way to build better models, improve sustainability, and ensuring that all parties who are part of this effort have their interests protected. And so another effort that is related to making US agriculture understood and also co-collaborating tools as well is a new initiative we have called the Farm Innovation Ambassador Team. We call it FIAT, which some people do associate with the car brand, but here it's standing for Farm Innovation Ambassador Team. So this is a formalization of a lot of ad hoc efforts that have been happening for years for folks who had originally been part of NASA Harvest, have worked in the agriculture space. And so building off of that idea that to run a lot of these models that are used for supporting farm decisions, we need access to data. In the US, it's a pretty specific enterprise because most of the farmers here, they are private sort of companies or entities. So in order to gain access to data, a lot of times that means that you need access to private land. So it's not as simple as we need data on soybeans. We can walk onto farms because most of that is someone's business essentially that you're walking onto. They've had a lot of these ad hoc relationships with farmers who have led us on to their property, who have opened up their fields to us. We thought it was time to sort of formalize those relationships. So this Farm Innovation Ambassador Team builds off the success that we've had in the past, working with farmers and keeping them sort of at the center of what we do. What we don't want is products that just sit on the shelf. We want our tools to be homemade. They actually have an end user and they're able to support decisions that are actually important to farmers. And so this is really seen as appending the traditional research model where it's you sit and you pick a study topic and there's limited interaction with farmers, but we're able to actually get into relationships with farmers and actually develop tools that they want. And so this is a new initiative. So we just launched our charter. So we have about 9 farmers from different crops, different geographies in the US who are part of our steering committee. And they helped us refine this charter that you see that really demonstrates the rules of engagement for how folks are going to be involved with this effort, different sort of what we call membership levels. And sort of what exactly is the value add to them, and ensuring that everyone is always on the same page. Because the worst outcome that we envision is that people leave unsatisfied with the relationship. We want to make sure that everything is equitable and equal as much as possible. So a lot of these efforts here for our innovation ambassador team, so it's like sort of like why now? So we want to make sure, again, that data computed models, they are helpful for those of us in the practitioner and research space. And so we want access to the data for innovation. We realize this innovation requires creativity and collaboration is essential for adoption and also reach. And so the photo here, which I love, is our FIAT co-lead, Ignacio Champiti, who is out of Purdue University, and Ray Flickner, who's a farmer from Kansas. They have a really strong history together, and they helped inspire FIAT because they work very closely together. Ray Flickner has a Flickner Innovation Farm where he invites researchers to do a lot of data collection through his land. And so we, again, wanted to formalize these relationships that we sort of had throughout the years, just one project will reach out to a farmer, or folks will lead us to others in their network. But we wanted sort of a formalization, have a charter, have folks who are formally signed up and allied with us in a brand new way. So ensuring the values of co-creation, collaborative, high touch, meaning that we're in frequent contact. It's at a specific place. So, for example, the Flickner Innovation Farm is in Kansas, but can be scalable to other farms, other places across the US, and also multidisciplinary. We have different geographies, there's different crops in the US. So, having ones, and we envision, perhaps in every state doing different crops, different types of growers, smallholder, large scale, specialty crops, etc. And then also dynamic and responsive to the different needs. There's extreme weather that's happening across the US at any given time, and needs just necessarily change because we're not only dealing with the climate in terms of weather, and weather as well, but also with the international sort of economic system as well. So planning to be dynamic and responsive to different needs as well. So that's an exciting innovation that we have as part of the group as well. And I'm going to get into a little bit more about this impact area of increased understanding of US ag. I'm showing the map again of our different partners, our research and development partners that we have at the University of Maryland, and then stretching all the way across the US. And I want to just then talk a little bit about what frames a lot of this work. And that's our essential agriculture variables, or EAVs, as I'm going to lovingly refer to them for the rest of the presentation. And if you haven't heard of EAVs before, you probably have had worked with them without calling them that specifically if you're in the agriculture remote sensing space. So EAVs, we like to just call as an integrator. They meet multiple information mandates from the global remote sensing community, and they also are an internally coherent set of variables that meet the needs for a lot of people who are in the remote sensing of agriculture space. So the key commonality between all of these variables is that they are remotely sensible and they bring simplification. So this was in response to a lot of international initiatives that came forth in 2018. And then the EAVs started immediately after from the GeoGlam initiative, which I'll get into the next slide. But EAVs, they use satellite data, they are remote sensible, but sometimes other data sources to create information that's useful for agriculture. And we like to talk about them as building blocks. They help us understand what's happening. So I'll have examples in the next few slides with things like soil moisture. Soil moisture alone is probably not going to be the only variable that you use to make a planting decision, but it is remotely sensible. And with other information, it can help make on-farm decisions. And so they're generally just parts of the agriculture system that we can map, or things that we could do with the right satellite information. And so just a little bit more of the history. The EAV initiative was started by the Group on Earth Observations, which is shortened to GEO, Global Agriculture Monitoring GLAM System. So GeoGlam are the adjectives or abbreviations that you'll hear refer to this effort. So the early focus was on crop monitoring and food security, again, because this was mostly born out of an international effort. And so it first originated in drafting lists from 40 candidate variables. If you go to agvariables.org, you can see the full list of them. And so they're constantly, even now, going through refinement through GeoGlam, international partners, and that includes NASA, European Space Agency, and others that involved in order to make this coherent sort of set of variables that are sort of the standard for agriculture monitoring. And so an important thing here is that the purpose is not to like overpromise on remote sensing can do, but have an actionable list on what is measurable and where it could be insightful. So having this sort of EAV list be the authority in some ways on what we can do with remote sensing in agriculture. And so in general, here on your screen are some example EAVs and a general, like my categorization of them. And you could argue that EAVs fit into multiple categories. So for example, for ones that are relevant for agriculture, I believe are crop production, so crop yield forecasting, the rangeland condition, crop yield estimation. We have our land cover and land use, crop type mapping, field boundaries, sizes, delineations, a map of rangelands, for example, soil and water resources, so canopy nitrogen content, evapotranspiration, soil moisture, and then also management practices, things like land management calendars, irrigated cropland maps, and tillage intensity. So there's a whole other suite um, of ones that you could also view again at this agriculturevariables.org. And I know Wally mentioned sharing the slides later, so you can take a look at those if you're interested as well. So next, I'm just going to go over two quick examples of how NASA Acres partners have been contributing to these EAVs in this larger impact area of understanding US agriculture. So this is an example of a crop type mapping that's born out of the global efforts that Matt Hansen and the GLAD Lab do based out of the University of Maryland. So they create these global maps of agriculture and cropland. And then they're also able to look at different types of crops. So here in like the bottom right call out here, we have soybean and corn. And a lot of their really great efforts are providing these free maps for you to use in your own research and also work. And then you can trust through here, a lot of this background accuracy assessment is done through field sampling, do a lot of field work, verifying their mapping efforts. And again, posted online, you can see the results of their papers and also the sort of science that goes into behind creating these maps. So another effort that happened this past summer is we had Avarice flights, a high-tech aircraft from NASA's Jet Propulsion Laboratory, captured hyperspectral imagery over a lot of the Cornell, sort of like New York, upstate New York fields there. They flew over sort of a Cornell Agritech, Cornell's Ithaca campus, and different centers there in order to get data that will be useful for things like predicting harvest yields in the region, spotting crop issues before they're visible, improving disease and water management. And this is all led by Dr. Katie Gold, who's out of Cornell, who is a great pathologist who not only incorporates hyperspectral now into their work, but also a lot of robotics technology in order to do early detection of disease for grapes in sort of places where they grow for vineyards, which is a agriculture need there. So next, I'm going to go into a little bit more about our sort of last impact area that I'm going to share, and that's workforce development. So developing agro-tech skills in sort of the next generation of people who are interested in farmers and people who are sort of younger and just getting into deciding what they want to do for a living. And then also folks, later who maybe want to make a career change into aligned, maybe remote sensing farming support as well. So one initiative that we're excited about that just started this fall is that we partnered with Garden City Community College in Garden City, Kansas, and also Kansas State University to offer a course that introduces students to technology and agriculture. So we don't go and teach the class there, but we have a wonderful instructor who's executing the course, Lisa Mai. And it's a 15-week course over the fall semester. So we provide and collaborate on curriculum related to introduction to remote sensing and GIS, having them use different phone apps. So the picture you can see there is them taking survey measurements out in a field by their classroom. A little bit ago, the core does not necessarily look like that anymore in Kansas. But learning how to use these tools for GPS, also getting them in front of the computer, looking at free resources like QGIS, how they can access satellite data, how they combine different data sources to do something like slope mapping or different types of water and cropland data to understand what they can gather information for to make on-farm decisions or consult others. A lot of the folks out there in Garden City are interested in becoming crop consultants. So having the knowledge in order to tell others what decisions they could be making on their farm is important. And then also getting them some information about those careers in agriculture, how the skills that we provide them in their course could be helpful for things that they want to do potentially in the future. And so this is the first pilot class that we've had, and we're excited about it, potentially being able to spread to other places in the United States, different community colleges, different certain styles as well. And a lot of this effort is led by Jacob Orser and Michael Humber here at our program office at UMT. And so I wanted to just talk a little bit about NASA Harvest and NASA Acres. I had mentioned before that some folks who will be speaking to you later in the week are affiliated with Harvest or have been in the past. And so they're different, but we have common characteristics. So NASA Acres is US focused, NASA Harvest is global. And so Acres, we focus on our own farm and range tools, data privacy and autonomy, which we went over, and our essential agriculture variables and workforce development. So we were established in 2023, and our executive director is Dr. Alyssa Whitcroft. And then NASA Harvest, again, they focus on more national to global policy support, food supply, markets and trade. It's the executive director of that consortium is Dr. Inbal Becker-Reshef, and they were established in 2017. But we are the same in the sense that we are both led at the University of Maryland. We have our core funding from NASA to sort of seed start to start us, and then our vision is to grow. And we rely a lot on strong collaboration, focusing on advancing EO methods for the benefit of the agriculture community. And we are really driven by needs for tools and also information as well. And so the last slide I have here is those free training resources. This is just a small suite, frankly, of efforts that are online. So 3 that I want to point out just here, and if you have questions about more free resources, I'm happy to talk with you offline about those. But NASA RSET, it's advanced remote sensing training, essentially, that's offered by NASA. So they have online training, and they also have some in-person trainings happening every now and then about how to use EO observations. And they have different applications. So they have ones focused specifically on agriculture. When I went to the website recently, you just scroll for a while and you can see a lot of resources that they have. So it is targeted more for an intermediate to advanced audience, but they have really great tutorials. They have the code available for you where you can just sort of like plug and play with the coding scripts and the data examples that they provide. So you can learn about things like how to ingest information from NASA in order to create maps that are helpful for agriculture. So those are a really great resource. I personally use those and they're fantastic. There's another effort called NEON. I was born out of the National Science Foundation. They have a lot of different tools as well. They don't have a section that's specifically focused on agriculture, but when you look through their tutorials, they have ones like basic R programming, basic Python programming, how to ingest Landsat images or create different indices that would be helpful for agriculture, So that's also a similar model where they have coding scripts online, they have slides, webinars, and they also are able to then provide you with example data. So those are really great if you're learning, if you need to brush up on some stuff, or you just in general want to share with others as well on how they could use remote sensing in their uh, operations. And then for us at NASA Acres, we have more of a primer information here. So just NASA Acres remote sensing, where we had a need expressed from farmers that we've talked to that folks are like, well, I don't even know what you can do for me. We took that to heart and have started creating some primer resources about the fundamentals of remote sensing, how satellites work, what they can see, what they can't see. And so that's information that we've been working with online in partnership with farmers to make it more easily accessible for someone who is brand new to remote sensing, but could benefit from the information. So encourage you to check all those out, especially for folks in the US. A lot of them are focused and provided by the US government here. And so with that, I will close. I will thank you for your time. Again, thanks to my expressive sixth grade, Molly, Waleed, Vlad, and others who have allowed me this platform to share a little bit about the great work that partners are doing and other folks at NASA Acres and NASA Harvest. I invite you to email me if you have any questions. You want to chat a little bit more about agriculture remote sensing. I could talk to you for hours about that. And with that, I will open it up to any questions and hand it back to Waleed if there's anything for him. So thank you all so much.
Thank you, Alison. That was great. I learned more about the NASA Acres initiative since it's new. Yeah, I will open it for the audience. If you have any question, please type it in the Q&A and the chat. Alison, we do have, I don't know if you have access to the Q&A section.
I think I have a chat, and
Okay.
Yanti, that's great. I'm glad that RSET training, you have an advocate for them and you learned a lot and have applied them in your research. Yeah, I don't
Um,
work for RSET, but I'm here to sing their praises all day.
so I have a question actually in the Q&A section. I'm not sure why
Great.
you're in it. Yeah, so we have a question. What role does the agro training program play in addressing the low trust rate among farmers? Only 27% trust share in their data.
Yeah, so I think like I don't know if, and maybe Lena, you can correct me if I'm like misinterpreting it. But I don't know if agro is if you're referring to something specific. If that is like a specific initiative. I personally have not heard about it, but I would say in general, like our efforts in like sort of the workforce development and training others, I would say that's a really great question. And I would say that what we're trying to do in a lot of our workforce development, especially that community college class that we were mentioning, is just having folks who are new be familiar with what the data can do. So in general, like for example, we had the students open QGIS. They were able to interact with some slope data, some DEM data, and maybe the best short response is just exposure. Um, some of the students are, from farm families, some aren't, but sort of just getting them exposed to it and then understanding what is possible. And then from there, sort of like word of mouth telling their friends. And if they go on to become, crop consultants or folks who work more intimately on farms for their living, just having people understand that the purpose of the satellite imagery and folks who want to integrate farm data with satellite imagery is to support decisions. It's sort of like stops there. There's Yeah, and I think that's sort of where I would end my response there. And again, if agro is something that I'm not familiar with, I would love to know more about that. Then I see, I think there's another question, and Waleed, I'll keep going, and then you
Yes.
stop me. Okay.
Go ahead.
I would
Thank you.
say, so I'll read the question out loud for folks who don't access the chat. But among the EAVs, the essential agricultural variables, which one do you consider the most challenging to consistently measure across the US using remote sensing? That is an excellent question. I would say it really depends, and I'm gonna get like a little bit like probably on a little tangent here, but honestly depends on your expertise. Uh, because if you, for example, if you only work in the optical imagery side of the spectrum, you might not be familiar with synthetic aperture radar, which can do more soil moisture, right? So there could be just like a limitation on what folks know that they can do, and we only have training in certain ones. I would say up until recently, and I think this is a good plug for the new NISAR mission that just launched. Um, Soil moisture evapotranspiration, given the technology that we had, was very limited to larger scale observations. But now with NISAR, we get like centimeter observations. So I think I'm not going to necessarily say that it was the hardest. I think hardest depends on your training and what we have access to. But that has opened a lot of doors to where there were previously challenges. So the new the dual NASA and ISRO Indian Space Agency satellite that just went up that just collected images, I think this like past 2 months. I think that has opened the most doors recently. Hardest personally, I think surprisingly, for me personally, just not in general, it's like field boundaries. I think it's really hard to delineate from space because it's so can be potentially a little bit ephemeral exactly where the field boundaries are. And exactly what we're doing with EAVs is what actually is a field? And when you think about it, like, oh, it's just where like the geometry is. But maybe not necessarily. It could be fallow for a little bit, for a few years, and then you come back to it and then you plant again. It could be pasture. So I think every single one has its challenges. And I think what I learned through just like learning about remote sensing is with, especially with like land cover types, is if you ask someone who specializes in water remote sensing, they're going to say that's the hardest. If you're like me and wildfire mapping, I'm going to say that's the hardest. Because I think the more essentially to get to your question, it's like the more depth you have in something, the more you realize the limitations of things. Um, so it can be a little bit of a the more you know, the less you know type situation. But I think I'll just leave it at there's a lot of really great movement happening and possibilities with soil moisture evapotranspiration. I see with this new NISAR is going to be really open up the doors. But I don't see any more questions in the chat, and I want to thank you for those questions. Those were awesome. Um, so I'll turn it back to Waleed or anyone else who has any questions, and then I'll put my email in the chat for anyone who wants to continue to talk offline.
Thank you, Alison. Just to go back to the comment of Lina and the interest on the SAR data on the remote sensing. So we're building a session on the use of NISAR since we have, so NISAR is, as Alison was mentioning before, is the last, recently there's a launch of um, a radar mission, and it's between NASA. It's a collaboration between NASA and ISRO, the Indian Space Agency. And we're building a session that if we're able to get it together, we're gonna announce it soon about the use of NISAR on the specifically in the agriculture session, since we have the data actually and we have a workflow on how to use this data and what type of insight we can get from this data. Alison, I have more questions for you. Here you go. I'm just copy and paste from the question and Q&A. I don't know why you don't have access to them, but
Oh, I think I
just
have access to it now. Thank you so much, Molly.
perfect.
So
Okay.
I'll just read out the question.
I don't know if it's a question, but yeah, go ahead.
Okay. Some of the final, I'll just summarize it briefly. Final year agriculture student from India working on SAR data for rice crop and flood monitoring. Really interested in a career in precision ag, good online resources like the technology in agriculture and any opportunities in NASA Acres or similar programs for remote students. So I will say the ones on the slide you should have access to from anywhere. The NSF resources, and which is the I don't know if they have a name for it actually, just NSF tutorials, and then the NASA RSET agriculture, sort of like combined ones. They have ones for wildfire, they have ones for air quality, but they have agriculture specific tagged ones that you should be able to access from there. And then I can share with you, let me see if I can stop sharing. I'll just share with you here and sort of like the live Q&A. We have a web form that you can fill out if you want to sort of like get involved and if things aligned. But those should get you off to a good start, the ones that I linked in the chat there or linked in the presentation. And if you don't have access to those, please, you can reach out to me and let me know. We can look for other ones that you'd be able to access with your specific internet connection.
Great. I think we still have 3 minutes before our break, and then we come back. So I think yeah, if we have more questions, unless that we will take a break and we start again at 10:30 with the presentation from Dr. Molly Brown about the use of remote sensing for food security. So yeah, and please make sure to fill the form. I'm keeping it in the chat because sometimes when people leave or get back, they don't see it. So just to be included to in our upcoming sessions, that will be maybe when we have like sessions that are more technical, as like this the new SAR data, we'll have one session or like one day only concerning the SAR data, and that's what we are trying to build it, like how to use the data, what is the let's say upcoming or like what kind of insight we can get from that data for the agriculture and mainly soil moisture when we talk about the radar data and the NISAR. But we have also other sessions that we are trying to build with other institutions and other experts for specific interest. So this is said. We'll meet again at 10:30. See you. Thank you.